Hello everyone, welcome to my channel ProChem Academy. Now in today's video I will discuss another topic of chemical bonding. That means another type of bond I will discuss. Okay, this is only for class 10 and class 9. They can watch this video. Okay, for all the boards, that means ICSE also, CBSE and the West Bengal board students also. Okay, if they want the basic concept of your chemical bonding, they can see the video. Okay, so let's start the class now. So chemical bonding, so last day you will see I have done a video. That link of the video you will get in the description box. There I have discussed about the ionic bonding. There I have discussed about the ionic bonding, and I told you that I have discussed only one example of ionic bonding, or that means only one electron dot structure of the ionic compound. But today I will start a few examples. I will again give few examples. After that I will go into the covalent bonding. Okay, so here you see that. So last day I have taken the example of sodium chloride. Okay, this is done. Now I will start with the calcium chloride. Now this calcium chloride is an ionic compound. Why? Because this one is calcium is metal and chlorine is non-metal. So there the electronegativity difference is very high, so they can form an ionic compound. So today we will see how we can write the electron dot structure of calcium chloride. This is trivalent compound. Okay, that means 3 atoms are here, calcium and 2 chlorine. So for that we have to write first of all we have to note the atomic number of each. So here you see the atomic number of calcium is 20, for chlorine is 17. Now we have to write the electronic configuration. Okay, so here for chlorine the electronic configuration is 2887. Okay, for calcium it is 2882, and for chlorine it is 287. Now according to Lewis we have to show the outermost electron, because the valence electron will only participate in the reaction. Here the valence electron are 7 for chlorine, for calcium it is 2, and for chlorine it is 7. So we can know the valence electron. Now only the valence electron will participate in the bonding, not the inner electrons. Okay, now this calcium, the valence electron is 2. So how will we write? Here 1, here 1. Okay, and for chlorine, how many electrons are there at the valence? 7. So here we write chlorine 7 electrons. So we want to write the as pair. Okay, that means 7 electrons are there. 2, 4, 6, 7. And for this chlorine 2, 4, 6, 7. Now as calcium has 2 extra electrons in its outermost shell, okay, so after releasing these 2 electrons it will get stability, because after release of 2 electrons it will get the electronic configuration 8 at the outermost. So it will try to release the electron and it will get the stability. So here this calcium will transfer 1 electron to the chlorine and another electron to this chlorine. So calcium is transferring 2 electrons, so calcium is getting calcium 2 plus. Okay, and here chlorine, each chlorine is getting 1 electron. So electron gain means it will transfer into the negative charge ion. That means it will form the chlorine. Understood? That means it is forming a chloride ion. Here also chloride ion. Now what is the electronic configuration become? See here 288 and here 288 also, and here 288. How? Because this chlorine has got 1 electron, so it is also stable, and this is also stable. Now the compound will be electrically neutral, so these 2 positive charge will be neutralized by these 2 negative charge. So here you will get calcium chloride. This is the formation of calcium chloride, electron dot structure. Okay, and these are the Lewis symbol. Okay, so if examiner asks you to draw the electron dot structure of calcium chloride, you will draw like this. Okay, any doubt? If any doubt is there, you can ask me in comment box. Okay, now next is that, say again another one I am giving example. Magnesium chloride you can do similar way. Magnesium chloride you can do as a similar way. Okay. Now magnesium chloride you will try. If you cannot, you will tell me. Okay. Now see for calcium oxide. Calcium oxide. This is also ionic compound. Okay. See calcium atomic number 20, that means 2882, electronic configuration, valence electron 2. Now that means 2 extra electron is there. Okay, from the octet. And here oxygen having 6 atomic number 8, that means the electronic configuration is 2, 6. Okay. Now what will happen if oxygen get 2 electron, it will be stable. And here again, if calcium release 2 electron, it will be stable. So what will happen? We have to show the outermost electron here, because these are the valence electron. Only valence electron will participate in the chemical reaction or bonding. Oxygen here also 2, 4, 6. Okay. Now if this oxygen gets 2 electron, then it will be octet. Okay. So as this oxygen gets 2 electrons, so it will be 2 minus, and calcium release 2 electrons, so it will be 2 plus. So here calcium oxide. Here it is calcium oxide. Okay. Now if any class 8 student who are, if in class 8 book chemical bonding is there, you can see this video. Okay. So the class 8 student calcium can also see this video. Okay. So it is the formula of calcium oxide. Understood? Now other ionic compounds like calcium chloride, magnesium chloride, calcium oxide, sodium oxide you can do. So you can try. Okay. You will try, and if any problem is there, you will tell me. Okay. Now next is covalent bonding. Now in covalent bonding, the same rule will not be applied as the ionic bonding. That means same way will not proceed, but the concept will be similar. That means every atom in a covalent compound will try to be stable. That means it will try to get in octet electronic configuration. Okay, except hydrogen and helium. It will try to get the octet electronic configuration except the elements which are having not more than 3 or 4 electrons. Okay, so they will have the duplet electronic configuration. Okay, so normally in covalent bonding, not complete transfer of electron will be there, otherwise they will share the electrons. The atom which are participating in the chemical covalent bonding, they will share their electrons. Okay, they will share the electrons to each other actually. Now how they will share? They will share like that. They will be stable. Now, so the first procedure is that sharing of electrons will be there between the atoms. Between the atoms, sharing of electrons will be there between the atoms. Okay. Now same case here, that in case of ionic bonding we have seen there is a difference between electronegativity is much higher. Here less difference of the electronegativity will be there. Okay, less difference of the electronegativity. Now, okay, less difference, not less, that means difference in the electronegativity. Okay, between the atoms, less difference in the electronegativity between the atoms. They will show the covalent bonding. Understood? They will undergo the covalent bonding. Now just I am giving one example, that see hydrogen molecule. How hydrogen molecule is formed? It will form by a covalent bond. Because here no alkali metals is there, no non-metals is there. Okay, so it will not form the ionic bond, rather it will form covalent bond. Okay, now how it will form? 2 hydrogen atom will join together having each one electron. Okay, now it cannot share also, it cannot share, it cannot transfer also the electron. So how I will show that? I have to show one valence electron, because each hydrogen having one electron. Now what we have to do, that if each hydrogen gets 2 electron, okay, it will be stable by duplet rule. Okay, so what will happen? This hydrogen will share 1 electron with this hydrogen. Understood? So it will be stable. Again, this hydrogen will share one electron with this hydrogen. So it will be stable because both are getting two electrons. As both are getting 2 electrons, so they are getting stability. Okay, but complete transfer of electron will not be there. Actually, they will share the electrons. Now, how will I show the sharing? That means we will make a circle to show the sharing of the electrons. Okay, now if this hydrogen gets 2 electrons, it will be stable. So by taking this 2 electron, we will make a circle. Okay, so this hydrogen is stable. Now again for this hydrogen, by taking this electron, we will make a circle. So this is also stable. Now in between these two circles, this region having 2 electrons, okay, this showing a bond. These 2 electrons are forming a bond between this hydrogen and this hydrogen. So they are actually, by sharing the one electron, they are making a bond between them and they are getting the stability. Okay, and that bond is nothing but the single bond, and for the one single bond we need 2 electrons. We need 2 electrons. So hydrogen molecule is forming. So it is hydrogen. So this is called covalent bond and single bond. So in a one molecule of hydrogen, how many bonds are there? Only one single bond is there, and that consists of 2 electrons. Okay. Now we will see some examples which will have 2 bond or 3 bonds or like that. Okay, so multiple bond can form, but single bond, double bond, triple bond will be highest. Okay, so for one single bond we need 2 electrons. For 2 bonds we need 4 electrons, and for 3 bonds we need 6 electrons. But likewise they will form, they will get the stability. Okay, now this is for hydrogen. Now another example you will see for oxygen. Okay, homonuclear diatomic molecule, because these are atomicity is 2, but both are similar. Both are oxygen atom. Similar with the oxygen, hydrogen. Okay. Now this oxygen having atomic number 8, 2,6, 2,6. Okay. Now this oxygen will show the outermost electron as paired. 2, 4, 6. And this oxygen will show the outermost electron 2, 4, 6. Okay. Now we will make a circle to get, if we get the 8 electron for a particular oxygen. Okay, for each oxygen, if we get the 8 electrons, it will be stable. So what will happen? This oxygen will take the 2 electron of these 2 electron of this oxygen to get the stability. Not completely it will be taken, but sharing will be there. So we will make a circle. We will make a circle. So 8 electron. Okay. Now here also, this oxygen will have 8 electrons, 2, 4, 6, 8. Now in between two circles you see 4 electrons are there. These 2 electrons will make one bond, these 2 electrons will make one bond. Okay, 2 bonds are formed. This is the bonding. Okay, that means the double bond is there between these 2 oxygen. Now you see these electrons are not in between these 2 regions. These 2 electrons, that means these 2 electrons and these 2 electrons, that means electron pairs, are not participating in the bonding. Okay, so they are the lone pair of electrons. These are the lone pair of electrons. So here these are the lone pair of electrons. Lone pair of electrons. So what do you mean by the lone pair of electrons? The electrons which are not participating in the formation of bond. The electrons, the pair of electrons actually, the pair of electrons which are not participating in the formation of bonding, they are called lone pair of electrons. Now how many lone pair of electrons are there? For this oxygen, 1, 2. These 2 electrons making one pair. These 2 electrons making one pair. So 2 pair, 3, 4. So how many lone pair of electrons are there? 4 lone pair of electrons are there in a oxygen molecule. Okay, this kind of questions are coming actually. They can ask you that how many lone pair of electrons in a chemical oxygen molecule. So that in that case you have to see the, you have to write the, actually you have to draw the Lewis dot structure, that means electron dot structure. Okay, so this is the electron dot structure of oxygen molecule. Okay, electron dot structure. Now say another one, I'm giving example, nitrogen. Okay, each nitrogen having electronic configuration 2,5, 2,5. We will arrange the electrons, we will show the Lewis dot, that means electrons. Likewise we can make the outermost electron 8. Okay, proper way. So here 5 electrons, how will I show? 2, 4, 5, I will not show like this. I'll show like this 3, 4, 5 because to show properly the bonding. Okay, here also for this nitrogen 2, 3, 4, 5. Now we have to get 8 electrons for individual nitrogen. For this nitrogen 2, 3, 4, 5, 6, 7, 8. Okay, and for this nitrogen 8. Now in between these two circles you see 3 bonds. We can write here these 2 electron 1 bond, these 2 electron 1 bond, these 2 electron 1 bond, and these are the lone pair of electrons. How many lone pair of electrons are there for this oxygen nitrogen molecule? Count. It is 1, 1. That means 2. So it is nitrogen molecule. Done. So these are the Lewis-Dot structure of homonuclear diatomic molecule: oxygen, nitrogen, and hydrogen. Okay. We can form the heteronuclear also. One will be hydrogen, another will be fluorine, chlorine, like that, bromine, like that. Okay, we can make. One example I am giving. See, HCl. HCl is a covalent compound, hydrogen chloride. There is a no IUM is that shortcut I have told you. IUM should be there in a compound for the ionic bond. Sodium chloride is the ionic compound. Okay, but HCl for hydrogen chloride, no IUM is there. That means it is a covalent compound. Now one hydrogen, one chlorine having electronic configuration this. Okay. Now this hydrogen having one electron, you have to show like this, and for this chlorine 2, 4, 6, 7. So here, so for this hydrogen, if it gets 2 electron, then it will be stable. So make a circle. And for this chlorine, if it gets 1 electron, because it is already 7, if it gets 1 electron, it will be stable. So make a circle. So here hydrogen, in between these two circles, 2 electrons are there. So it makes one single bond. These are the lone pair of electrons. So this is HCl. So HCl is a covalent bond compound, which is this one. Okay. So as your HW, you will try to do for this one HH similar way, HBr. Okay. Atomic number of bromine is 35. You will try for C2H4, CH4, CCl4, C2H2. Okay. Or otherwise, next video I will do this one. Okay. So try. And if you have any doubt regarding this covalent bonding, you can ask me over comment box, so I can reply you properly. Okay. So thank you for this class. If you like this video, then do like, comment and subscribe my channel. Thank you.